quite know. All right, 1.7 exponents. All right. It's kind of like a review, but guys, we're going to do a time. Well, that's probably going to be tomorrow. I don't know. We'll see. Maybe I will give you homework today. Who knows? All right. That I don't care if you take back your thank yous. Okay.
We'll also take back homework.
Taylor, that is annoying.
Say everything you want to say.
All right. What is the big three called?
Full numbers.
Base. As your base. What is this called? Very good. Exponent. You got to remember base and exponent. You're off to a great start. And does this mean 3 times 4? How would I write that?
3 times 3 times 3 times 3.
Very good. This is the exponential form. Hopefully y'all remember that. Remember it has the word exponent in there. Does anyone remember what this form is called? Raise your hand. What?
Expanded form?
Yes, sir. That is expanded form. Very good. So you have your exponential form. If I said to put it in an exponential form, that is what it looks like. If I say it needs to be in expanded form, that's what it looks like. Raise your hand if you can tell me the answer. Gabby? 81. Make sure you write all that down. I'll let you catch up. All right. When you're done, put your pencils down so that I know you're done. Okay, otherwise I think you're still taking notes. I got 2 stars here. If I have -3 to the power 4, remember these? Anyone want to tell me if they remember how to write that? Taylor?
Is it
No.
just 3?
Let's see, Gabby, do you remember? There you go.
Oh.
And when there's no parentheses here and your base is negative, you have the negative on the outside, everything on the inside. And that would give me a what? What would the answer be? Yep. I just taught 7th grade this. And they're like, oh, no. I said, yeah. What if I have this, Taylor? How would I write that one?
Is that one negative?
Yep. -3 times -3 times -3 times -3. And what would that answer be? Raise your hand. Aiden? +81. Very good. Notice the difference. I told the 7th graders, I said, trust me when I tell you, because I started showing that, oh, we can remember that. No, you're not. You're going to have to look back at your notes. It gets confusing. I said it happens to all of us, including your teacher. I'll look at that and I'll have a student say, is this the one, or is it the other one? Well, let me think about it for a minute. It's hard to remember. It's easy to forget. Okay? Keep in mind, when there's a parentheses like this, then we're keeping it in parentheses. Notice that -3 to the power 4, -3 to the power 4, and we get 2 different answers. So it actually does make a difference. Yes? No, because it depends on the exponent.
Oh.
If it's even or if it's odd.
Oh.
See what I'm saying?
Yeah.
This one, though, no matter what the exponent is, it's always going to be negative. See, the 7th graders didn't pick up on that, but that's okay because it's brand new to them. But with this one, this top one, it doesn't matter the exponent. It's always going to be negative. This one, not always. Good. Any questions so far? All right. Multiplying and dividing with same bases. Here we go. Sixth grade's so cute, y'all. I did this little thing, and they were like, yes, I said, what is that? Oh, that means and. And they, can I just write the word and? Do I have to write that? No, you can write the word. I'm having trouble, Mrs. Rogers, writing that. I can't write that, Mrs. Rogers. Then just write the word and. Mrs. Rogers, what does that mean again? And. It means and.
It's literally on the keyboard.
I will start writing the word and from now on. 10 minutes of this in notes. It's that great.
Mine is a 3, but this
Yes. Okay, so multiplying and dividing with same bases. When multiplying with same base, what do you do the exponents? Does anyone remember? If you're multiplying and the bases are the same, we what to with the exponents? Raise your hand. Raise your hand. What?
I was gonna say you add them.
You are correct. When multiplying with same base, add exponents. When multiplying with same base, add exponents. And I'll give you an example when everyone catches up. Five squared times 5 cubed. Emily, are the bases the same? So then what do we do the exponents? So then this would be 5 to the power 2 plus 3. Were they just running?
Yes.
It's too late. It's too late. They went that way? Well, I gotta pause this. Okay, so if the bases are the same, we add the exponents. That would be 5 to the power of 5. And then you'd work out, but we're not going to work out. Any questions? Do we remember this?
Yeah.
What if I had x 3 times y to the 4th times x squared? I can't? Cecilia, can I combine anything here?
X and X.
Ah, are we multiplying everything? Yes, we are. This x times y times x, when there's no operation sign that and they're right next to each other, it means we're multiplying. This base and this base are the same. So Cecilia is correct. It would be x, and since we're multiplying, the bases are the same, we add the exponents, so it would be 3 plus 2 times y to the 4th. And 3 plus 2 is 5, so your answer would be x to the 5th power times y to the 4th power. Good job. Make sense, guys? Okay, see, the thing is, last year, it was challenging enough with learning all this stuff. This year, they're going to try to trick you in every way. Your homework, some of it is going to resemble some of the stuff that I used to show y'all last year to scare you. But y'all got this. You just, if you try to rush, you're going to make a mistake. So attention to detail, take your time, look for clues. All right, any questions about multiplying with same base? All right, let's do when dividing with same base. When we're dividing with same base, what do we do the exponents, Michael? Very good. Okay, so when you're dividing, you're going to subtract exponents. For example, 8 to the power of 5 divided by 8 to the power of 3. If we're subtracting, now remember, with dividing, whatever number you put down first makes a difference. The first one always comes first. So it's 5 minus 3, which gives you 8 squared. And what is 8 squared? Gabby? Because 8 times 8. Very good. Okay, so we're subtracting exponents. Now, any questions? What if I do this? 8 to the 3rd divided by 8 to the 5th. Am I going to get the same result? No way, man. Because this time, Michaela, I have 3 minus 5. Do you see that? Do you see the switcheroo? The 5 here came first. This time the 3 came first. So what's 3 minus 5, Michaela? Oh no. I have a negative exponent. Who remembers what to do to get rid of that negative exponent? Michaela, do you know?
Add it to the 8. I don't know.
Oh, you missed the first part of the year, so. Wit?
Oh. Don't you move the sign to the 8? And then, like,
No. No. Y'all forgotten what to do with negative exponents? Can we have negative exponents? So no one remembers how to make them positive? Michael.
Yes, you just get rid of it.
I throw it away?
Yeah.
You have to do something to get rid of it.
Multiply it by 0.
Aiden? Yes.
That's the answer.
You bring it to the bottom. Denominator. Do y'all remember this? Oh, y'all have to remember this. I better make sure my 7th graders really learn this. You have to bring it to the bottom.
when you bring it to the bottom, there's no negatives.
That's right. To make this positive, you put it in a denominator. Very important.
How'd you choose the numerator? Is this always going to be 1?
Unless, okay, not always, but if it's all by itself, yes, it's going to be under 1.
Wait, what do you mean all by itself?
Like there's nothing else here. I'll show you in just a minute. So then this would be 1 over 64. Ooh, I found something that y'all forgot, man.
We forgot most of this.
I mean,
Yeah, Gabby's really just making us look good.
yeah.
Thank you, Gabby.
She has forgotten too.
Oh, wait, sorry. Thank you, Gabby.
All right. So when things are negative, to make them positive, we have to put them in the denominator. All right. Let's say I have I'll talk more about negative exponents later. Let's say I have 8 to the 5th power over 8 to the 3rd power. What operation's taking place here? Division. Are the bases the same, Emily? Okay, so what am I doing to the exponents?
I don't know.
Okay, what operation is taking place? Okay, so if we're dividing, because it's a fraction, then we subtract exponents. Make sure you have the top number goes first minus the bottom number. That's going to be 8 squared again.
Are your examples just 8 squared at the end?
No.
And then it becomes some form of 64?
Shh. No. I mean, that's just what I'm doing right now to make it easy.
Wait, so it'll always be subtraction, like with the 5 minus 3?
Yeah.
Oh, okay.
Because when we're dividing, look right here. When dividing, if the bases are the same, we will always subtract. Always subtract. What about, look at this. What if I have 8 to the 5th power divided by 8 to the negative 3 power? We don't need to put this under 1 and make it positive yet. You first combine what you can, and then you can mess with that. How would I set this up? Emily, are the bases the same? What am I doing? So what do I do to the exponents? Subtract. So look here, guys. I have 5 minus negative 3. Common mistake? Kids put 5 minus 3 and call it good. This negative sign better always be there. So a negative in front of a negative, Emily, is what? So that's really 5 plus 3, which is 8 to the 8th power. No, I'm not going to go any further.
That's a big one.
Yeah, that's why I'm just leaving it. So guys, common mistake. Kids leave this negative sign off. They just want to do 5 minus 3. That negative sign, or that minus sign, had better always be there.
So it's not bad.
Okay, do y'all understand?
Yes.
If we're multiplying and the bases are the same, what do we do the exponents? No.
What was the question?
If we're multiplying and the bases are the same, we add the exponents. If we're dividing and the bases are the same, we subtract the exponents. Need to have that memorized. What about who remembers how to do that? Gabby? You multiply exponents. So, Gabby, what's 2 times 4? There you go. And if you were to work it out, you would get this answer. And you better hurry. Write this down.
Rubber grid and solution.
Seriously. And I can't believe you guys forgot so much. You have this written down? Write it down. So when the exponents are on the inside and outside, you're multiplying them. Okay? Y'all gotta have that memorized. We're going to talk about, and I'll move it up, properties of exponents. I'll move it up as soon as Aiden gets done. You got it all? You sure? Okay. And on the other side, if you've missed anything, you can get it from Cecilia or Taylor. All right. The first one, and we've been talking about these, product property. Basically, that's the one if the bases are the same and you're multiplying, you add the exponents. So x to the a power times x to the b power. Bases are the same. We're multiplying, so Michaela, what do I do the exponents? Very good. A plus b. Over a little bit. Okay, second one is the quotient. Remember, product means what? What does product mean? Multiplication. And quotient means what? Division. So quotient property. That is saying x to the a power being divided by x to the b power. Emily, are the bases the same? And what operation are we doing? Division. So what do I do to the exponents? Yes, ma'am. So it's x to the a minus b power.
So just forget about the other ends.
You just combine the bases.
What if they're different?
If the bases are different, then you can't combine them. You would just work them out. Like if it was 2 to the second power times 3 to the third power, you wouldn't be able to do this. You would just do like 2 to the second power is 4. 3 to the third power is 27, so and then multiply them. You'd have to actually work it out. These are just properties if the bases are the same. Okay, and then the third one is the power property. That is saying x to the a power to the b power. And what did we say you do? What do you do to the exponents here, Michael? You multiply them. Right here. When you have the exponent on the inside and outside, you multiply it. Any questions so far? All right, I got more for you. What if I had x to the 0 power? What's my answer? Raise your hand. Okay.
0.
No. Ace. No.
One.
Taylor.
What?
What?
What if I have 4 to the 0 power? Cecilia, what's my answer?
That's really weird. It has to be 0.
10 to the 0 power. Aiden.
1.
Very good. Anything to the 0 power is
1.
Oh, that makes sense. Think about it. 'Cause there's
not really.
No,
yeah, because
something
if it's x2, then
to the power 1 is itself multiplied by 1.
it's not getting multiplied by anything. So this wait.
A million
Never mind.
x
Never mind.
0.
Am I
confusing
really?
myself.
0.
I'm confusing myself.
Aiden.
Kind of looks like the
It's nothing to be multiplied by
I know.
Yeah.
It does look like the degrees. I had the 6th graders have already learned this in their chapter this year. It was on their quiz, and a couple kids got an answer wrong, and they said, well, but that looks like degrees, like x or 4 degrees or something. I said, tell me, when have we learned about degrees this year?
Exactly.
And they're like, okay. And where did you cut? What is 4 degrees? How did you get the answer you put
What
down
answer
there?
did they put?
I don't remember, but 4 degrees is 4 degrees. It doesn't mean anything. So and I was like, no. And they were mad. I'm sorry. Okay, do y'all have everything?
Yes.
All right. Now we're going to get back to negative exponents. You know what I love about teaching 6th grade and Algebra 1? Because you were all there once. And I get excited seeing how far my students come just from 6th grade to 8th grade, or 7th grade to 8th grade, or 6th to 7th. It's cute. The 6th graders, I mean, even though I'm having to explain and to them and, which side of the paper to start, just stuff like that, they're starting out. It's like a clean slate, and I know that they're going to get to where you're at, so that's kind of exciting, though I won't be there to see it. All right, negative exponents. Guys, if you have a negative exponent, to get rid of it, you put it in the denominator. In this case, there would be a 1 there.
It'll always be 1.
It won't always be a 1.
It won't?
No, I'll show you in just a
Oh,
minute.
yeah.
Now, what if I had a negative exponent in the denominator already? How do I make it positive? Raise your hand. Let's see, someone besides Gabby. Let's see. Cecilia, do you want to take a guess? If I have a negative in the denominator, how do you think I can make it positive? Just tell me. Do what again? Do you put it what? So move it on top? Or move it below more? Well, you're on a roll, Gabby. So where do I move it? To the numerator. So in this case right here, this was considered like a whole number. You would move it to the denominator. In this case, it's already in the denominator, so we're going to move it up on top. And that makes it positive.
Oh, it's
For example,
so then it just goes to a whole X.
it goes to a whole. We're going to do some examples here.
The X is
For example, 3 squared to the negative 4th exponent. Okay, if I have an exponent on the inside of parentheses and outside, Emily, what do I do with them? Yes, ma'am, you multiply them. So that is 2 times negative 4. And Emily, what does that give me? 2 times negative 4. Negative 8. Good job. Now, Cecilia, that is a negative exponent. How do I make it positive? Put it in the denominator. And in this case, we're going to put under 1. And instead of continuing to solve it, I'm just going to stop right there. Because I need y'all to just understand that. Okay, do y'all understand that part? Yes?
I just feel like when you're solving it, would you just do like 3 to power 8 and then just put 1 over?
Yep. Yep. Absolutely. That would actually equal 1 over 6,561. That would be the actual answer.
That's a 6,561.
Yes. Do y'all understand this? Okay. Let's do another. What if I have 3 to the power of 0 to the power of negative 4? Michaela, what is 3 to the power of 0?
1.
So then it's 1 to the negative 4 power. Which is basically 1 to the negative 4. Now, can I have a negative 4 exponent? Michaela, what do I need to do to make it positive?
You're going to do 1 over 1 and then 4 is the little item.
And what is 1 times 1 times 1 times 1?
1.
1.
What is 1 divided by 1? There's your answer. So 3 to the power of 0 to the power of negative 4 is 1. Yes.
Why would you multiply 0?
Well, okay. What is 0 times negative 4? Huh? Get the same answer, right? Ah.
Wouldn't that be fast?
Yeah, but you have to also understand how to take things out. Yeah, you can do it both ways. All right. Any questions so
Wait,
far?
Should we write that down?
Yeah, I'd write it down.
So you said do both?
No, you can do one or the other. All right, another example. What if I have 2 to the negative 3 divided by 4 to the negative 6? Are the bases the same, Emily? No, so we can't combine those. But that's a negative and that's a negative. Cecilia, can I have a negative exponent? What do I need to do? Put this one where? Where do I put it? Huh? Well, does it have to be over 1? Where do I need to put it? In the denominator, right? Because it's not always going to be under 1. So this needs to be in the denominator. What about this one? Where does it need to be? Above. Y'all see that?
Wait, why though?
This is negative. You can't have a negative exponent. So to make it positive, you bring it on top. You bring it on top. This is negative. You bring it on the bottom to make it positive.
Okay, so they're both negative, and you just flip them.
Well,
Take away
it's,
the negatives.
you got to look at each individual thing. This is negative. To make it positive, you put it on top. This is negative. To make it positive, you put it on the bottom.
Oh.
Let's do another one. What if I have 2 cubed positive 3 divided by 4 to the negative 6? Michael? Both of them? You put this on the bottom? Everyone better be paying attention, because all this stuff's going to be on your test, and it's not easy. Do I need to move this to the bottom? Why not? That's right. Guys, look at this. It's positive. We don't need to do anything with it. It can stay where it's at. But what about this one? Huh? This one has to go on the top because it's negative. So it's 2 cubed times 4 to the 6th power. And then you get your answer. And I'm not going to spend time working it out.
That equals question mark.
So, guys, you need to stay focused. It's not always going to be under 1 or over 1. And you're not always going to move everything. You only move the things that have negative exponents. You only move the things that have negative exponents. This had a negative exponent, so we had to move it to the bottom to make it positive. This had a negative, so we had to move it to the top to make it positive. This is positive, so it's staying the same. You could even say all of this over 1. This was negative exponent, so we had to move it to the top as a whole number. Michaela.
So if you make it over 1, then the answer would have to be over 1 too? Or it's like, it doesn't really matter, right?
It doesn't matter, because a whole number, like if I had this, that is the same as that.
And why is it multiplying? Why isn't it like subtracting?
Because you're going to be multiplying.
Okay.
Trust me. All right, let's do another.
Wait, I'll write that.
What if let's do letters. What if I had x negative 2y4. Someone want to try this? Taylor?
So, is it y4 over x powered?
Yep. There you go. The only thing, notice this, the x had a negative exponent, the y did not. So the y gets to stay on top, the x with the negative exponent goes on the bottom. Is that starting to make sense? Sometimes, believe it or not, some kids say, oh, the letters scare them in algebra. And then other times, after you've been in algebra a while, it's like, I'm so confused. Oh, yeah, I get it now. Sometimes the letters actually help. So you're only going to move the things that are negative. Does that make better sense? All right. Any questions? Okay, so we're going to stop right here.